On February 14, 1994, engineers at NASA's Jet Propulsion Laboratory sent a command across nearly 4 billion miles of empty space. And then they did something no engineering team had ever done before with an active spacecraft. They told it to stop looking. Not because it was broken, not because it had failed, because keeping its cameras on any longer would have burned through power the mission needed to survive for decades to come. But before that camera went dark forever, it turned around one last time, pointed itself back at everything it had ever known, and took a series of photographs that would leave some of the most experienced scientists in the world quietly speechless. This is the story of Voyager 1's final images, why they almost never got taken at all, and what happened when one of them turned out to contain something nobody expected to see. Stick around, because the story behind these pictures is stranger than the pictures themselves. And if you want more real space history explained without exaggeration, subscribe now, because there's a lot more of this mission left to cover. To understand why these final images mattered so much, you have to go back to what Voyager 1 was actually built to do in the first place. It launched on September 5th, 1977, on a mission that was, on paper, almost modest. Fly past Jupiter, fly past Saturn, take some photographs, gather some measurements, and then drift onward into the dark. NASA planned for a mission lasting 4 years, maybe 5. Nobody involved expected this spacecraft to still be operating, let alone still making headlines nearly half a century later. But Voyager 1 kept going. It passed Jupiter in March of 1979 and sent back the first genuinely close-up images of that planet human eyes had ever seen. It passed Saturn in November of 1980, and instead of slowing down, it used the gravity of each planet like a slingshot, gaining speed, gaining distance, covering more territory than any human-made object ever had before it. By 1980, Voyager 1's primary mission was technically complete. It had done everything NASA originally asked of it, and then some. At that point, the spacecraft was still carrying a fully functional imaging system, the same wide-angle and narrow-angle cameras that had captured Jupiter's storms and Saturn's rings in unprecedented detail. But it was also heading somewhere no camera would ever have anything meaningful to photograph again. Out past Saturn, the spacecraft was aimed on a trajectory that would eventually carry it out of the solar system entirely, through vast stretches of essentially empty space, with nothing nearby worth pointing a lens at for years at a time. This created a real and difficult decision for the mission team, one that doesn't get talked about nearly as much as it should. Voyager 1 runs on power generated by the slow radioactive decay of plutonium inside 3 onboard generators, and that power supply only shrinks over time. It never gets replenished. Every single watt used to keep an instrument running is a watt that isn't available for something else, and every year, the total amount available keeps dropping. With the cameras aimed at nothing but empty space for the foreseeable future, engineers made the call to power down Voyager 1's imaging system in 1980, redirecting that power toward instruments that could still gather meaningful scientific data out in the dark. For the better part of a decade after that, Voyager 1 flew through space essentially blind, still transmitting information about magnetic fields, cosmic rays, and plasma, but with its cameras switched off and silent. That's where the story could have quietly ended. A camera turned off in 1980, never turned back on, its final photographs simply being whatever it happened to capture on the way out past Saturn. Except one person on the mission team wasn't willing to let it end that way. Carl Sagan, an astronomer and one of the most well-known voices in American science at the time, had been pushing for years for one specific idea, and it wasn't a popular one inside NASA. He wanted Voyager 1 to turn its camera around one final time and take a picture of Earth from the outer solar system, not for any specific scientific measurement, not to gather new data. He wanted it purely for the perspective it would offer, a photograph of our own planet from a distance so extreme that Earth would appear as nothing more than a single point of light lost in the glare of the sun. Sagan had been proposing this idea since as early as 1981, and for years it went nowhere. Some engineers on the team were openly against it. Pointing the camera back toward the sun risked permanently damaging the optics if sunlight hit the sensitive imaging equipment at the wrong angle, and reactivating a system that had been powered down for years carried its own real risks. There was also a practical argument working against it. The image wouldn't produce any new scientific information, it would just be a picture. For a mission built around rigorous data collection, that was a hard case to make internally. Sagan kept pushing anyway, and by the early 1990s, the calculus had changed. Voyager 1 had passed its last planetary target years earlier, and its cameras were sitting unused, with no further scientific imaging planned for the remainder of the mission. If there was ever going to be a moment to take the risk, this was it, because the alternative was simply never using those cameras again at all. NASA leadership eventually approved the idea, and the mission team began preparing for what would become Voyager 1's final active use of its imaging system before the cameras were shut down permanently to conserve power for good. On February 14, 1990, commands were sent out to Voyager 1, then already more than 7 billion miles from the Sun, instructing it to turn its cameras back toward the inner solar system one last time. Over the course of that session, The spacecraft captured a sequence of 60 images that came to be known as the family portrait, a series of photographs showing several planets of our solar system as seen from far beyond the orbit of Neptune, something no spacecraft had ever attempted before, and none has attempted since from that particular vantage point. Mercury was too close to the sun's glare to be captured safely. Mars, at the specific moment of the imaging sequence, was obscured by scattered sunlight in the camera's optics. But Venus, Earth, Jupiter, Saturn, Uranus, and Neptune all appeared in the sequence, each one reduced to nothing more than a faint dot or a barely there smudge of light against the vast darkness surrounding them. One frame in that sequence became something else entirely. But it helps to understand the full sequence first, because Earth's photograph wasn't captured in isolation. The family portrait consisted of a total of 60 frames, taken using a combination of Voyager 1's wide-angle and narrow-angle cameras, deliberately assembled into a mosaic that, when pieced together, would show 6 planets of the solar system in a single, sweeping composition. Neptune appeared as a faint bluish dot, barely distinguishable from the background stars around it. Uranus showed up as a similarly faint point of light, its actual disk far too small at that distance for the camera to resolve any detail at all. Saturn, despite its famous rings, appeared as nothing more than a soft, pale dot with no structure visible whatsoever, the rings that make it instantly recognizable from Earth completely invisible at a distance of billions of miles. Jupiter, the largest planet in the solar system, showed up as barely more than a bright point of light itself, its swirling storms and banded atmosphere, so vividly captured during Voyager 1's actual flyby a decade earlier, reduced to something indistinguishable from a star. Venus appeared as a crescent, catching sunlight at an angle that gave it a sliver of visible shape, one of the only planets in the sequence that showed any discernible form at all. Then came Earth. In that specific frame, our planet appears as a single pixel, roughly 0, 12 pixels across, suspended in a scattered beam of sunlight that happened to be refracting through the spacecraft's camera optics at that exact angle. That accidental beam of light, an optical artifact nobody planned for, ended up running directly through the pixel representing Earth, giving the photograph an almost impossible quality, as if it were spotlighting our entire planet inside an otherwise empty frame. Sagan later gave that specific photograph a name that stuck permanently in the public imagination. He called it the pale blue dot. What happened next wasn't really about the image itself, technically speaking. It was about what it represented once people actually understood what they were looking at. Every human being who had ever lived, every war ever fought, every empire that ever rose and fell, every person you have ever loved, all of it existed on that single, nearly invisible point of light, occupying a fraction of a single pixel, adrift in a beam of scattered sunlight 4 billion miles from where the camera sat. Sagan later wrote about the image in terms that went far beyond astronomy, describing it as a demonstration of how small and fragile our entire frame of reference actually is when measured against the true scale of the universe surrounding it. For scientists on the mission who had spent over a decade working with raw data, magnetic field readings, and cosmic ray counts, seeing Earth reduced to something that small in a photograph they had fought internally for years just to get approved produced a reaction that a lot of people involved described afterward as genuinely unsettling in the best possible sense of that word. If a piece of space history like that, one that's fully documented and still holds up decades later, is the kind of thing you want more of, go ahead and drop a like on this video right now. It genuinely helps this kind of content reach people who'd get something out of it. Here's the part of the story that tends to get left out entirely, though, and it matters just as much as the photograph itself. Once that imaging sequence was complete, NASA didn't just leave the cameras on. On the same day those final frames were captured, the decision that had been building for years was finally executed. Voyager 1's imaging system, the cameras responsible for every photograph the spacecraft had ever taken, from the swirling storms of Jupiter to the icy rings of Saturn to that last look back at a barely visible Earth, was deliberately and permanently powered down, not paused. Not put into standby, shut off entirely, with the software controlling it removed from active use, and the power that system had been drawing redirected toward instruments that could continue gathering useful data as the spacecraft pushed further into the outer solar system and eventually beyond it. From that point forward, Voyager 1 would never take another photograph again. Every image the world has ever seen, or ever will see, from that spacecraft was captured before February 14th, 1990. Think about what that actually means for a moment. Voyager 1 is still active today, still transmitting data, still one of the most consequential spacecraft in the history of human exploration. In 2012, it crossed the heliopause and became the first human-made object to leave the solar system entirely, entering interstellar space and continuing to send back information about conditions there that no instrument had ever measured directly before. But it has been doing all of that blind, without a working camera, for well over 3 decades now. Everything we know visually about what Voyager 1 has passed through since 1990, the outer reaches of the solar system, the heliopause itself, the edge of everything the sun's influence touches, exists only as invisible data. Magnetic field readings, plasma measurements, cosmic ray counts, numbers on a chart, not pictures. The last thing that camera ever saw was our own solar system, shrinking into a scattering of faint dots against an ocean of black, with Earth barely registering as a single pixel caught inside a beam of stray light. This is also why NASA has never seriously entertained the idea of trying to reactivate the camera. Beyond the power constraints, which remain a very real and shrinking limitation, there is genuinely nothing left for it to photograph. Interstellar space is not empty in the sense of having nothing happening scientifically. Voyager 1's other instruments have made that abundantly clear through the plasma and magnetic field data they've continued to collect. But it is visually empty. No planets, no moons, no rings, no clouds, nothing within any meaningful distance that a camera could resolve into an actual image. A photograph taken today would show nothing but a field of distant, unmoving stars, no different from what any telescope on Earth can already capture far more clearly. The imaging system that produced the pale blue dot and the rest of the family portrait sequence didn't just run out of power, it ran out of anything left to look at. That's part of why the family portrait sequence carries the weight that it does. The image itself didn't stay confined to scientific circles either, and that's part of what makes its legacy so unusual compared to almost anything else Voyager 1 ever captured. In 1994, Sagan published a book titled after the photograph itself, Pale Blue Dot, expanding on the themes the image raised into a broader reflection on humanity's place in the cosmos. The passage he wrote about the photograph, describing Earth as the only home we've ever known, suspended in a sunbeam, has since become one of the most widely quoted pieces of science writing of the 20th century, reprinted in classrooms, documentaries, and public talks for more than 30 years since it was first published. NASA itself has returned to the image repeatedly at key anniversaries, releasing a reprocessed, higher-resolution version of the original 1990 data in 2020 to mark the photograph's 30th anniversary, using modern image processing techniques that weren't available to the original team, though the fundamental content of the photograph and the profound thinness of that beam of light Earth happened to be sitting in remained exactly as it was captured on that single day in February. It isn't simply Voyager 1's last set of photographs by circumstance. It was, by design, meant to be exactly that. A final, deliberate look backward at everything the spacecraft was leaving behind, taken specifically because there would never be a reason or a chance to do it again. The engineers who approved that final imaging session knew precisely what they were authorizing. Not a new leg of exploration, but a farewell photograph, taken by a machine that was about to spend the rest of its functional life looking at nothing at all, at least visually, for the remainder of its journey into the dark. If you found this as strange and moving as I did while putting this together, drop a comment and let me know. It genuinely helps me figure out what to cover next. It's also worth understanding just how much risk NASA accepted in order to get that photograph in the first place. Pointing any spacecraft's optics anywhere near the sun carries a real danger of damaging the sensor, even from billions of miles away, because the imaging system was never designed with that kind of glare in mind during standard operations. Engineers had to calculate the exact angle needed to capture Earth and the other planets without exposing the camera to direct sunlight that could have destroyed the equipment in an instant, on the very same day it was scheduled to be shut down anyway. Every single frame in that sequence had to be planned with extreme precision because there was no room for a second attempt. If something had gone wrong with the sun angle on that single session, the mission would have lost the opportunity permanently, with no way to try again once the cameras were decommissioned. There's also a detail about the technology itself that tends to get overlooked. Voyager 1's cameras used a Vidicon tube system, essentially the same basic imaging technology found in television cameras of that era, not the kind of digital sensor arrays used in modern spacecraft, or even in the phone most people are watching this video on right now. The image data had to be transmitted back to Earth as a stream of raw numbers, essentially describing brightness values pixel by pixel, then reconstructed by teams on the ground into the images the public eventually saw. Given that Voyager 1 was already more than 3.5 billion miles away at the time and radio signals travel at the speed of light, each individual image took hours just to arrive back on Earth, using hardware that was already considered outdated well before Voyager 1 even launched in 1967. That the technology managed to produce something as visually and emotionally powerful as the pale blue dot, using equipment built in the early 1970s, transmitted across a distance that size, remains one of the more remarkable technical footnotes of the entire sequence. It's also worth remembering just how narrow the margin for error actually was on the ground back at Mission Control while this sequence was being planned. Every command sent to Voyager 1 at that distance took hours to arrive, and just as long for any confirmation to return. There was no opportunity to check the framing halfway through, notice a problem, and adjust on the fly the way a photographer might with a camera in their hands. The entire sequence of 60 frames had to be calculated in advance, down to the precise timing and angle needed to safely capture each planet without damaging the optics, then transmitted as a single set of instructions and executed automatically by the spacecraft itself with no way to intervene once the sequence had begun. Everything about that day depended on calculations made weeks earlier, holding up perfectly across a distance so vast that light itself needed hours to cross it. So what does all of this actually add up to? Voyager 1's final images weren't the accidental byproduct of a spacecraft simply running out of things to see. They were the result of a years-long argument inside NASA, pushed largely by one scientist who believed a photograph with no measurable scientific data attached to it was still worth taking, purely for what it could make people understand about their own place in the universe. That argument was won on a single day in February of 1990, on the same day the cameras that made it possible were switched off forever. Every photograph Voyager 1 has ever produced exists because of a decision that almost didn't happen, using a camera that was already scheduled to go dark, aimed at a planet that occupied less than a full pixel in the final frame. Voyager 1 has been flying blind ever since, gathering extraordinary data about interstellar space with instruments that don't produce pictures, and it will keep flying that way for as long as it keeps transmitting at all. Even now, more than 3 decades after that camera went dark, the photograph it produced keeps getting invoked in conversations that have nothing to do with spacecraft engineering at all, referenced in discussions about climate policy, in speeches about international cooperation, in classrooms teaching kids their first real sense of scale about the universe they live in. Very few single frames of data in the history of science have carried that kind of weight for that long, especially one taken almost as an afterthought. On the same day, the equipment that captured it was permanently switched off. If stories like this, real history, fully documented, explained without exaggeration, are what you come here for, subscribe to this channel and turn on notifications, because there's a lot more of the Voyager mission still worth telling. Thanks for watching, and I'll see you in the next one.